Today we're going to talk about the unit circle and basic trig. So to draw the unit circle, first we want to draw our two coordinate axes, the x and y axes. And from here, we then want to draw a nice big circle centered at the origin. So this will be our unit circle, and the radius of the unit circle is going to be 1. And so now that we have that, this is always going to be the unit circle. We want to think about how we're going to measure angles in this unit circle. So we all know the degree system, where if we go all the way around the circle, that's going to be 360 degrees. If we go just halfway around the circle, that's going to be 180. If we go fourth, that's going to be 90 degrees. If we go to an eighth, that's going to be 45 degrees. Just like that, 45 degrees. And so on. And we all know that we're going to measure every one of our angles starting at the positive x-axis. So we're always going to start with here. This is always going to be a side. So now let's think about another way that we can measure angles, and that's through radians. And basically what radians are is it measures angles basically based on how far they go along the circumference of the circle. And what I mean by this is if we had 2 pi radians, this would be equal to saying that we had a 360 degree angle, because since the radius of this circle is 1, we know that the circumference is going to be 2 pi r, and that's going to be 2 pi. So if we have a distance of 2 pi along our circumference, that's going to go all the way around, and we're going to have 360 degrees. Likewise, if we have pi radians, that's just going to go halfway. So we're going to have 180 degrees. And then if we have pi over 2 radians, that's going to be half of 180. It's going to be 90 degrees. So if we have the angle from here to here, that's going to be pi over 2 radians. And so this angle, this 45 degree angle is going to be pi over 4 radians. That's going to be 45 degrees. So we can also write this, or pi over 4. Now let's try a trickier angle. Let's try 3 pi over 4. What is 3 pi over 4 going to be? Well, if we think about it, if this is pi over 4 and this is pi over 2, then pi over 4 plus pi over 2 is going to equal 3 pi over 4. And since this is 45 degrees and this is 90 degrees, we know that this 135 degrees is going to be 3 pi over 4 radians. Now, if we weren't able to just use our common knowledge and our intuition to figure out the angle measurements, we could have also used another method where we say, since pi radians is equal to 180 degrees, then we can set up a proportion, and we can say that 3 pi over 4 radians divided by pi is going to be equal to x, the angle measure in degrees that we want, divided by 180 degrees. And this works because we're saying up here that pi radians is equal to 180 degrees. So you're basically, the concept is you're dividing both sides by the same thing, only in different measurements. So here we multiply both sides by 180, so we get 3 pi times 180 degrees divided by pi times 4. The 4 is going to jump down there, and that's going to be equal to x. And so now we can divide this by 4. That's going to be 45. We can knock out that 4. We can knock out the pi's. And so we're going to be left with 3 times 45. That's going to be 135 degrees equals x. So we are absolutely right with that. Let's try another one. Let's say that we have 4 pi over 3. What is 4 pi over 3 going to be in degrees? Well, if you think about it, if pi radians is equal to 180 degrees, then if we divide both sides by 3, this is going to be 60 degrees. So pi over 3 is going to be 60 degrees. Now if we just multiply that by 4, we're going to have 240 degrees. But we can also solve with our proportion, where we go 4 pi over 3 divided by pi. It's going to be equal to x divided by 180. Multiply both sides by 180. We're going to get, let's see, 180 divided by 3, that's going to be 6. 4 times 6 times pi divided by pi is equal to x. So, or let's make this a 60. And then we're going to do 4 times 60 is 240 equals x. So 240 degrees equals x. And we're going to draw this in. If this is 180, we're just going to go 60 degrees past that. So it's going to be right here. And so this angle right here will be 240, but this angle right here is going to be 60, and that's going to help us later on when we do trig. And so if we think about trig, we know from the past SOHCAHTOA. Now if we review what SOHCAHTOA means, that's basically telling us that sine, so S equals O opposite over hypotenuse. So, and then cosine equals adjacent over hypotenuse. And then TOA, the tangent, equals opposite over adjacent. So we're not really going to use tangent today, but let's focus on sine and cosine for now. How do we figure out sine and cosine using the unit circle? Well, let's think about if we had the angle 45 degrees or pi over 4. This is a little bit messy. We're just going to deal with it. So let's say that we had pi over 4 here. If we're thinking about sine, that's going to be opposite, so this is going to be opposite over hypotenuse. And we know for sure that the radius, shouldn't have erased it, but our radius is going to be 1. So our hypotenuse is going to be 1. So this sine is just going to be the length of the opposite side. And likewise, our cosine is just going to be the length of the adjacent side. So we know that our sine, here I'll use a different color marker for this, our sine is going to be, oh, that's not very good, oh well. Our sine is going to be right there. It's going to be the opposite. It's going to be the height. And we know that our cosine is going to be our ground distance right here. So this is sine, and then this is going to be cosine. And this is special for the unit circle since the radius is going to be 1. So let's think about this pi over 4 triangle. And we know that pi over 4 is equal to 45 degrees. So we know that from geometry, our 45 degree triangle, 45, 45, 90. This is a 90 degree angle. If we want to figure out the lengths, we know that 1, if this is 1, then this is 1, and this is going to be your square root of 2. We can either memorize that or use the Pythagorean theorem since this is a right angle. Now we don't want a square root of 2 right here because we want the radius. We want this is going to be our radius. We want this to be equal 1. So what happens if we divided everything by square root of 2? We would get a proportional triangle where this is 1 divided by square root of 2, and this would be 1 divided by square root of 2. And if we chose, we could say that 1 divided by the square root of 2 is equal to square root of 2 divided by 2 because we would rationalize this fraction. So now we can say, since this is 1 and cosine is adjacent over hypotenuse, that our cosine of pi over 4 is going to equal square root of 2 over 2. Kind of messy, but that's what it's going to equal. Now, next we're going to go sine of pi over 4. And our sine is going to equal the same thing. This isn't usually the case, but in this case with our 45 degree triangle, this is going to be special. Now, just for a bonus, let's think about tangent. tangent would be this length divided by this length. And so since we know this and since we know this, and they're the same thing, if you divide something by that same something, you know that you're going to get 1. So our tangent of pi over 4 is going to equal 1. Very simple. So now let's try a harder one. Let's say that we had the angle of 2 pi over 3. So 2 pi over 3 in degrees is going to equal 120. That's alright. So this is going to be 120 degrees. Now we need to figure out a nice triangle that we can look at to figure out these lengths. Length right here, the height, and then right here along the graph. So to do this, since we know this is 120 and this is going to be 180, this has to be 60 degrees. So we have a 30, 60, 90 degree triangle. Just like that. And this is going to be your right angle, and this is going to be your 60 degrees. And so from geometry, we know that if this is 1, then this is 2, then this is square root of 3. But we don't want that to be 2, we want it to be 1. So let's create a triangle in which we take all 3 of these lengths and we divide it by 2. So this is going to be a 1, this is going to be 1/2, can you guys see this? And then this is going to be a square root of 3 divided by 2. Just like that. So we have 1/2 here, we have a 1 here of course, and then we have square root of 3 over 2. But one problem is that this 1/2 is going in the negative x direction. So this is actually going to be a negative 1/2. And so now we can use this information and calculate the sine and cosine and tangent just as an extra of this triangle. And so since we know that sine is the opposite side, we know that sine of 2 pi divided by 3, it's a really messy s, is going to be square root of 3 over 2. And we know that the cosine, you have to be kind of careful on this, of 2 pi over 3 is going to be negative, don't forget the negative, 1/2. And then we also know that the tangent of 2 pi over 3 is going to be our opposite divided by our adjacent. So square root of 3 over 2. And when you divide, that's like multiplying by the reciprocal times negative 2. That's going to equal negative square root of 3. Now there's one trick for you to remember all of these things, and that's that cosine starts with a C and sine starts with an S. We're going to use another kind of starts with a abbreviating technique to memorize this, and we're going to say that cosine is the cat, because cats generally travel horizontally on land. And sine is going to be our seagull since it goes up into the air. So our sine is going to be our height, and then the cosine is going to be our ground distance. And so sine seagull and cosine cat, and that's how you remember it, and that's how you figure out trigonometric values using the unit circle.